rolling of hoop and disc on an inclined plane. Any smooth surface which makes certain angle with the horizontal. Any smooth surface which makes certain angles, which makes certain slope with the horizontal, and that is called inclined plane. That is called inclined plane. So first of all, we meet this inclined plane. H is the height, the ground है. तो हमारे पास सबसे पहले हम hoop की बात करते हैं. Let we have a hoop. Hoop ring कह सकते हैं, जैसे चूड़ी होती है उसको भी कह सकते हैं. And this is placed on the inclined plane, at the top of the inclined plane. Hoop possess potential energy at these positions, and this is what we call gravitational potential energy. Let a hoop ring is placed at the top of an inclined plane, smooth surface making certain angle with horizontal. At the top of the inclined plane, this hoop possess gravitational potential energy. Hoop possess gravitational potential energy. Now, hoop is allowed to roll down. We see that this hoop possesses two types of motions. One is linear motion, that it travels this linear distance along the hoop, as well as it is rolling down, that it possesses rotational kinetic energy also. The hoop possesses two types of motion, linear as well as angular. So it possesses two types of kinetic energy also. According to the law of conservation of energy, we can write loss of potential, gain in kinetic, linear and rotational. So mathematically, mgh is equal to half mv f square minus half mv I square plus half of I omega f square minus half of I square, where Vi is equal to omega I is equal to 0. So we can write mgh is equal to, in general, is equal to plus half I omega square. अगर हम इसकी वेलोसिटी निकालने के एंड के ऊपर इस हुप की वेलोसिटी क्या होगी, तो फॉर हुप I इज इक्वल टू एम आर स्क्वायर होता है. हुप का मोमेंट ऑफ इनर्शिया एम आर स्क्वायर होता है. तो एम जी एच इज इक्वल टू हाफ एम वी स्क्वायर प्लस हाफ ऑफ एम आर स्क्वायर ओमेगा स्क्वायर. अगेन एम जी एच इज इक्वल टू हाफ एम वी स्क्वायर प्लस हाफ एम वी स्क्वायर, because v is equal to r omega होता है. This is mgh is equal to mv square. तो यहाँ से v square is equal to gh या v is equal to gh under root. This equation determines the velocity of the hoop at the end of the inclined plane. When the body reaches the end of the inclined plane, then the velocity possessed by the hoop will be equal to gh under root. So it is very clear from this equation that velocity of the hoop depends upon the height only. Height जितनी ज़्यादा होगी तो velocity जो है वो भी speed या velocity उतनी ज़्यादा होगी. अब अगर डिस्क की बात करते हैं, डिस्क loss of potential energy is equal to gain in kinetic energy, linear or rotational. So mgh is equal to half m v square plus half I omega square. For disk, I is equal to half of m r square. इसलिए m g h is equal to half m v square plus half m r square omega square. This is equal to half m v square plus 1 by 4 m r square omega square. This is 1 by 2 m v square plus 1 by 4 m v square, because v is equal to r omega. So finally we can write mgh is equal to 3 by 4 m v square. gh is equal to 3 by 4 v square, or v is equal to 4 by 3 gh under root. So the formula, from this formula it is clear that the velocity of the disk also depends upon the height, number 1. और अगर हम कंपेयर कर लें हुप और डिस्क की वेलोसिटी को, तो डिस्क की वेलोसिटी जो है that will be greater than the speed of hoop, because here is 4 by 3 under root and 4 by 3 under root is greater than 1. So डिस्क की जो स्पीड है वो हमेशा ज़्यादा होगी as compared to the speed of the hoop.